I request all my team to please switch on the video. All the team members, please switch on the video. And miss your team also, please switch on the video. We are about to start. We are waiting for the judges to come. They have given their time from the busy schedule, so we have to wait for them 2 more minutes. They are joining. They are joining. Devasis, you are mute. Devasis.
Good evening, everyone. Welcome to the hackathon hosted by Emancipation Private Limited. I'm Devashish Tiwari, your host for today. So, as you all are acquainted with the fact that we are here in the final stage of this hackathon, and we have successfully accomplished the previous 2 ones. So let me first congratulate to each and every finalist out here that you have done really something really great, and congratulations for you too to successfully qualifying the first 2 rounds. And as we all know that this hackathon was mainly hosted to take the best out of the best. But the main motive of Team Emancipation was to give you a clear understanding on what DSA is, why DSA is, and how we can achieve all the requirements. And I guess the webinar was almost perfect to give you a clear understanding and all. And also we always try to make you understand why it is so important for the placement scenario. Now coming to the present, I would really like to thank, and we are really honored to have the presence of our chief guest as Abhishek Kumar sir from GLL, California, US. Prashant Jaiswal sir, he is a senior member of the technical staff from VMware, India, and Mr. Biddu Bhushan sir from Google, India. Thank you, sir, for your presence and taking the precious time and giving it to us. I would really like to thank to our team too, Mr. Shubir Chakraborty sir, our coordinator, Mrs. Shravani Chakraborty ma'am, our coordinator too, Mr. Ranjan Tiwari sir, our administrator, Mr. Anshu Ranjan sir, our IT head, and each and every member who has been associated with the team to make it a success till now. So now I would like to take you guys forward actually to our today's plan or today's schedule, what we are really going to do. And it is as it follows that you, all the participants who have came here, who have qualified the first rounds, the finalists. All the finalists will each one of you will get 10 minutes each for your presentation. The total marks will be 100 and will be divided accordingly as the team has decided. You will be called serially. You have to give your presentation and it should not go beyond 10 minutes. 10 minutes is the last deadline, and after that you will be asked to give a viva from our really able judges around here. And I would really like to thank the judges for their time, and I would really like to request you all to give your valuable experience and tips to us so that even with the finals, we could also learn from you all. So I would like to request my fellow anchor Radhashri to continue and to call the members as sequentially as planned. Thank you.
Unmute करो राधा.
Hello everyone, very good evening. I am Radhashri Bose, the second host of the day, and I am here to call the participants who are supposed to share their solutions with the judges. The first name in the list is Manvendu Pathak. Manvendu, I request you to kindly switch on your video and audio so that you can communicate with the judges.
Okay, before Manvendu starts, I would really like to request all the participants to turn off their video for the present, and also make sure you have turned off your audio so that there shouldn't be any noise or something like that, and let the participant give their presentation on the at their best. And I would really like to congratulate you for your standing here, and best of luck to each and everyone standing out here. May you give your best, and may the most deserving one win. Best of luck to all you guys. Head on. Manvinder, you can start your presentation right now.
So am I audible and visible?
Yeah, Manvinder, you're audible as well as visible.
I think the host should allow me to share my screen because it's, I think, disabled.
My backend team, please allow Manvinder to share his screen, please.
Share screen is allowed. You can start sharing.
Okay, so yeah. So yeah, a very pleasant evening to all the members and the viewers. My name is Manvendu Pathak. I am of SRMS CET Bareilly, currently pursuing my BTech in computer science in my second year. So the today's motive, or I have divided this presentation in three sections. I call it the to-dos. The first section will be the problem. The second will be the solution and approach. The third will be the code solution. So in the problem, I will be explaining the problem to the viewers. In the second section, I will be solving the problem and giving a brief info about the approach that I have used. And in the third, I will be discussing about the code. So moving on, the name of the problem is archery. So basically in this problem, there are n number of targets that are arranged in a line. So we can say that like this is target 1, target 2, target 3, and that continues to n. And we have also given these target number, like the leftmost target is given the number 1 and continues till n. So as there are targets, there will be archers also. So on each target, there are 2 archers that are assigned to compete with each other. So the total number of archers will be 2 into n, because there are n targets, and at each target there are 2 archers, so the total number of archers will be 2 into n. So this is the further one step in our problem. And continuing to the next part of our problem, there will be a competition between these two archers group, in which the one who is winning will move towards its left and the one who loses will stay at its position. The position of archer 1 on target 1 is always fixed, and the loser of the group 1 will be moved toward the last position, which is n. There will be r number of rounds in this competition, and the number of rounds is equal to the number of archers. So moving on to the next, that is the condition part of our problem. In this, we can see that we have arrived on time in the tournament, but all other players have arrived somehow early in the tournament. The total number of players that have arrived early will be 2 into n minus 1. That is, we subtract our value from the total number of archers. So we want to adjust ourselves in a position so that we will be winning and we will be close to the first group and start from the largest group as possible. So like if we take this example, there is a group of 1, 2, 3, 5, 6 and continues. So we want to put ourselves in a position in a line so that we are most close to the group minimum number of target group, that could be 1, and we start from the largest, that could be 3, 4 or any group depending upon the value of r. So there are rank that is assigned to each of the members, like 1, 2, 3, and that continues with the so on. The between two members whose rank is less, he will win the competition. Like for example, if we take the between 1 and 2, if the competition is between 1 and 2, then the archer who has rank 1 will win, obviously, because his rank is less. So we had the problem is we have to insert ourselves in the line in some way that we are most close to the minimum target, and we start at the largest group or the more for the group that we can. So coming to the solution and the approach, I have taken a sample input. For example, like 4 n, the value of n is derived like 4 targets, so the value of n will be 4. Like if there are 4 targets, n will be 4, and 8 is the value of r. 8 is also defined as total number of archers, or it is also defined as the total number of players or total number of archers that are playing, and it is also defined as the total number of rounds that are going on in the competition. So in this example, there are 4 targets and there are total number of 8 archers, and there will be 8 rounds that are going to held. And after that, in the input, there is an value, there are values given of ranks of different players that will be 8. The first rank is our rank, obviously. It is the rank 7. So we can say we are the second worst archer in this list of archers. So this is the first value, it's our value. We have to insert our value in between these groups, so we are more close to the target one, and we start at the largest of any target. So for example, if we are 7 and we get started in the, if we get our place in the target one, then as I said earlier, 4 values less than 7, so we are the loser, as we are, our rank is less than 4, our rank is larger than 4, so we are the loser. Then we will be transferred to the last of the target, and we will be stay here for whole of the match. If we are at the position 2, then we will be stay there, but our logic continues that we have to start at a large position, as large as possible, and continue to the minimum target or close to the minimum target as we can. So we can get in the third group. In the third group, like you have seen, the value is 8. So if we take the position of 5, between 7 and 8, our value is smaller. So we will obviously win in this competition, and we will be shifted toward the second target. Between 6 and 7, the value of 6 is smaller, so it will be shifted to the sixth target. It will be shifted to the first target. So we stay here for the whole of the tournament at the second target. So this is the problem. We can arrive at the second target also, but at that our condition will not satisfy. We have to find a larger value from which we have to shift. And at the four targets, it's obvious we will stay there for whole of the time, and similar in the first target. So this is the basic algorithm that we are going to follow. First, we are going to enter the values of n that I have said is the total number of targets. Then the value of r that I have said is the total number of archers or total number of rounds. Then we need to check that in which group we are going to win. And then after checking that in which group we are going to win, we are going to print that. So this is the basic algorithm, and this is the basic flow chart that I have made, in which continues similar as the algorithm. Moving forward to the code solution, I have tried this code in Java because I have keep my hands in Java in DSA problems only. So first of all, we will take a scanner class, and first we will input an integer value n from sc.nextInt, and then we will take a value of r, and after that we will initialize an array whose size is going to be the size of r, that is 8. So it will be 7 4 2 6 5 8 1 3. The size of the array will be 8. Then we are going to read the values of the array with the for loop. And continuing to the main part, first we will start with the for loop. So starting with the for loop, we will start from the value 1, not with the value 0, because 0 is our rank. So we have to compare that rank with other. So we will start the loop from 1, and then we will continue the loop to the last value, and we will check if the value of if the value of 7 is less than 4, then we will check another condition, that if the value of j, the value that we are starting, j, will be divisible by 2 or not. Like for example, in this particular input, we can see that we have started at 7, we will check by 4, it is not true, then 2, then 6, then 5. At last the value will be true at 8. So we will check the value of j will be 1 2 3 4 and then 5. The value of j will be 5. So we have seen that j modulus 2 is obviously not equal to 0, it is not divisible by 2. So we will directly print the group. For printing the group, we will do what? First of all, let me explain some of dry run mode code, like in this problem.
So you are requested to fire up if it's faster because we are running out of time.
Okay, sure, sir, sure. So this is the dry run of the code, and I have as shown in my PPT. For finding the group, we will just do the modulus sign. The total number of archers that are there will be modulus the position that we have found. And coming to the complexity, the basic complexity of for loop is always O of n, and there are if else condition in the inside of for loop, so it will be O of 1. So the total complexity of the algorithm will be O of n. So resting my PPT with a very good code that I found, programming isn't about what you know, it's about what you can figure out, by Chris Pine. So thank you.
Thank you, Manvendra, for the great presentation. You prepared, the hard work you showed. Now I would really request our judges to take on the quiz round or the Viva round that you want to ask to Manvendra. Please, sir.
Devasis, your voice is not coming properly.
Sir, am I clearly audible now?
Yes. The other three you can also take the mic. Okay.
So thank you, Manvendra, for the presentation you prepared.
Yes, sir.
And now I would really like to request our judges to go on with the Viva round, and you can ask accordingly. So please, judges.
So I'll kick it off then. I'm Biddu Bhushan. So nice presentation, Manvendu.
Thank you.
I had a question on your code. So in the problem statement, it was given that n is the number of targets and 2n is the number of players.
Yes.
And you'll be given ranks of the players in the next 2n lines. So when you were reading the input, why have you used r as your iterator? Like you had started from I equal to 0 going to I less than equal to r I plus plus. R is the number of rounds and not number of players, right?
No, sir. As mentioned in the question, there are equal number of rounds as well as equal number of players. So if like there are 8 players, then there will be 8 rounds in the competition. So that's why I have used the value of R in the reading of the array so that the whole value of the array can be read.
So my understanding was that R would be greater than or equal to 2n. I must have read it incorrectly in that case, but that was my understanding of the problem statement, that will always be greater than or equal to 2n. I can check the problem statement in that case. Yeah, R is not actually number of players. You can take a look at the problem statement.
Okay, sir.
Mr. Prashant Jaiswal. Mr. Prashant Jaiswal.
Yes, sir.
Yes.
Yeah, I'm just going through the problem statement. So, I mean, to me, at first, it looked like there could be a problem with the solution that you have provided. So I'm just trying to revalidate it. So
Okay.
give me some time. I'll just check in.
Okay, fine.
Abhishek, sir, if you're present, can you please go on with the questions, the Viva round? We will be really thankful, sir.
Yeah, sir, I have seen the problem statement. You are absolutely correct. The value of R is at least the value of total number of archers. So yeah, it will be the wrong code. If we increase the value of R, then there will be the shortage of array. Yeah, sir, I think I have just somehow mislead it in that part.
Okay. Okay, assuming that you had 2n over there, I just have one more follow-up. So in your algorithm, you mentioned that you'll find the group where you can win. Like, what if you have multiple groups
Uh,
where you as an archer can win? Then you'll take the group with the highest number. Like, you'll take the target with the highest number in that case, right?
as sir, I have added in my code, if we start from the beginning, so when we get the first group, we will just break the condition over there only. So we get close to the, so we get close to the first target and also get a maximum value that is close to that target. So like if the group is 3, 4, 5 in both these 3 groups, the condition is satisfying. So he will obviously go to the 3 group because we are starting from the zeroth position. So then it will break the for loop and print the value of 3 only.
Okay, in that case, you have to do this for R number of rounds, right? So there could be some player that could be behind you that comes, that wins in the previous round, comes to your place and loses to you. In that case, you go to the number lesser than that, right?
Yeah.
So let's say, so in this case, what I mean to say is the approach, at least to me, does not feel like it will give the optimum solution each time. So
Yeah, I mean, not going by the optimal as well. I'm just seeing like the solution itself has a flaw.
Hello, Prashant, sir. Sorry to
Yeah.
interrupt you. Can we please have your video on?
Sure. Yeah, is it fine now?
Yes,
Yeah,
sir. Thank you so
so
much.
I'm just checking the code now. So it looks like it has a flaw, right? So the moment you say, because you have only 2 loops, and out of that, one is like it says I less than n, right? So what exactly it is doing? It is filling up the array with n positions, right? So and what value it is taking?
Sir, in my code, I think. Yes, sir, I have used the I value less than R. So it is just reading the input from the user of the size according to the size of the array, which is 8 and yeah.
And then you do a comparison, right? So, I mean, which I am not clear, like what exactly it is comparing and how are you achieving and going to that answer 3?
Sir, I am just comparing with the ranks of the players that are next to it. Like from the starting, I'm comparing the rank, which is the like we have a rank 7 and it is the second worst archer rank. So I will be comparing with it the ranks that is higher than the rank of 7. So it is the only possible case in which the archer can win because the rank is lower. And in other cases, the archer will obviously lose and would not be able to move towards the target one. So that's why I have added the comparison statement.
Okay, so did you try with some other test cases as well?
Yeah, I have tried with the some other test cases. Like there were 2 test cases in the problem. The main problem that I come into was like if the position is like even position, like the total number of archers are 8, the value of r is 8, and the condition at even we find the position as 2. So the modulus of that will be obviously 0. So we cannot found the group. So I try to make another comparison if a statement in which if the modulus of 2 is equal to 0, that means if the position is even, then we will just print the quotient, or if the position is odd, then we will print the remainder.
Okay. Okay, I don't have any follow-up questions.
Thank you, sir. Thank you.
Judges, do you have any further questions? Can you please let me know?
Just one final thing. What will be the space complexity for this problem?
The space complexity, sir, will be similar as the array size. The array size that we are taking and the size of the array, sir, there is a flaw in my problem. And the size of the array will be around like the value of total number of R value is the 2 into, and that is total number of that we are taking the target. So the value will be O of n, I think. Space complex.
Okay, that is all I had.
Thank you.
For your questions. And I would really like to request you all to give some of your valuable tips and experience to all of us so that we all can learn from it.
Devasis, your sorry to interrupt, your voice is not coming properly.
Sir, now
Thank you, Manvendu, for your beautiful presentation, and thank you, the judges, for such great questions. I would like to welcome the next finalist, that is L. Mohan Raju. Can we please have your audio and video on? L. Mohan Raju finalist, can we please have your audio and video on? Okay, sir, I guess there is some problem with his presence. Can we move to the next finalist, Harshit Gupta? Can we please have your audio and video on? Harshit Gupta finalist, can we please have your audio and video on?
Hello. Am I audible to everyone?
Yes, you are.
So, okay, so let me start with my presentation. So,
Harshit, before you start, I would like to remind you that you have been given only 10 minutes for your presentation, and then there will be a Viva round. So make
yes,
sure
sir.
presentation
Yes, sir. Thank
10
you.
minutes. Okay.
Okay, sir.
Head on.
So let me just share my presentation to everyone. So is it visible to everyone?
Yes, it is visible. You can hear me.
Okay, so good evening, everyone. I'm Harshit Gupta, and I'm currently studying in IIT BHU Varanasi and pursuing BTech in Mechanical Engineering Department. And I am feeling very delighted and grateful to be with all of you here. So let me start with my solution. So first of all, the problem, the archery problem, it feels me to be a very good one, and it took us just make to just build up what may be the algorithm. So just let me start. So everyone is aware of what the problem is. So let me just start with the algorithm and solution part. So let's first discuss. So the aim for the problem is let call our concerned archer H. So our aim is that our final position should be as close to target one as it can go. So it should be as close to target one as it can go, and such that we start from an initial position that is as right as possible. So this is the aim of the solution, the aim of the problem. So let me share with you the goals. So actually, I felt it to be a very time consuming problem. So it is basically, if we try a trivial solution of this problem, so it will be O(n) square into R. And I reduced it to O(n) cube, and it itself to just optimize it to n cube, it felt me to be very good task, because it is a very good problem. So let me come to the algorithm part. So basically, a trivial solution for this problem will be to like try out all the possible initial positions for the archer, the concerned archer H. So we will try out all the initial positions from target 1 to n, where it could be, and we will check for the R rounds. And to do this, to just check it for R rounds, we will need a complexity of O(n) square. So this will give out a complexity of O(n) square into R. For R rounds, it will give complexity of n square into R. So here is an approach to reduce this complexity to n cube. So basically, I'm coming to the algorithm part, the main algorithm part. So in this problem, we have taken two sets from the initial array that we will input. The array basically means the rank and the position that we are entering from the input. So we are making two sets. So first of all, the first set, I'm calling them noobs because their rank is greater. So I'm calling them noobs. So I will select these candidates from the rank n+2 to n. I will include those archers whose rank are n+2 to n, because they will not be able to win from the archers who are lesser in rank than these. So basically, from n+2 to n, there are total n-1 archers, and the other set, I'll call them pros. I'm calling them pros, and these are from the rank 2 to n+1. So these are the two sets, and we have not yet include the archer number 1, who is basically the most talented one. So in this question, when n-1 rounds are done, so we can obviously say that archer number 1 will finally come to target 1. I'm not saying that exactly it will take n-1 rounds. It will, in the worst case, it will come to the target 1 in n-1 rounds. And when it comes to target 1, because target 1's winner will doesn't move, so its position will be fixed from that instance. So now if we include the archer number 1, say W, to the noobs, so because these are the people whose position will not change with time after they have arranged themselves in the array. I'll show after some time. So now I have included the W to the noob set, and now noobs plus W has become n archers, and the other one is the pros. So now I'm just considering the noobs plus W set and I'll just check because these are the ones who will be able to move in the question. So basically, there are two scenarios. First one is whenever a archer moves from this set, whenever an archer from this set has a game with an archer outside of this set, means the noobs plus W has a game with pro, then noobs plus W archer will stay on the target and the other archer will move left. I'm considering this instance after n-1 round. So W has already fixed its position. So basically noobs will move, and whenever they have a match with the archer that is pro, so the noobs will not move. And the second scenario is when the noobs plus W set, the two archers we take from noobs plus W, and they have a competition with each other. Then one of them will, with a rank lesser rank, will move to the target on his left. So basically these are two scenarios if we consider noobs plus W. Now I after trying out many inputs and simulating the input,
Sorry to
I have
interrupt,
come to the
Harshit.
yes sir.
You have to go a bit faster because you're running late.
Okay sir, sorry. So now maybe after 2 n rounds, we can call that noobs will occupy 2 to n targets. In n-1 rounds, W has already occupied the first target, and the other in after other 2 n rounds. So basically 2 n rounds, noobs will occupy 2 to n targets, and with every target having exactly one noob. So after, I'm just saying this, that after 2 n rounds, all the archers in noobs plus W set will occupy exactly one target, and in every target there will be exactly one from this set. So precisely saying, within n rounds after W has arrived at target 1, every target will have at least one noobs plus W member on it. That is what I'm saying, and now I'll prove this scenario. So just to prove this, like we did in maths, we considered a lemma, and then we considered that this statement is not true, and then we tried to prove it by its contradiction. So in statement 1, I said that after n-1 rounds and within n rounds after the n-1 rounds have passed, so every target will have at least one noobs plus W member on it. So now it is obvious that once a target is occupied by noobs plus W archer, so then this target will always be occupied by at least one of them, because they can never win with a person who is from the pro set. So this is because noobs plus W archers never move out of their target unless there is another noobs plus W archer to challenge their position. Thus, if the above statement, let's consider our above statement to be false, so there must be a target in the whole 1 to n targets such that they that let's say the target be A. So in this particular targets, noobs plus W, there are no noobs plus W archers. So it must be true for some target A. So then the target to the left of A, let it be B. So after within one round, it is.
Excuse me, Harshit. I'm really sorry to interrupt you, but we would like you to wind up a little bit faster.
Okay, ma'am. So I was saying that if A is never occupied, I have considered the target A, and I'm telling that if A is never occupied by noobs plus W archer, then I'm saying that let us consider a target that is just in left to the A. So it would have at max one such archer within one round, and its position will be fixed. I can prove this. Because let us consider that A has two archers that are from pro set. So in after one round, one of them will move to the left, and if one of them moves to the left, then we can say that the left target will have at max. I'm not saying that there will be exactly one from the noobs plus W set in the left of A. I'm saying that at max there can be only one archer from noobs plus W. So within 2 rounds, and after we have tried this B, then within 2 rounds, the target to the left of B would have at max one noobs plus W, because same condition applies. And if we cyclically go to whole of the array or whole of the targets, then within n-1 round, the target to the right of A would have at most one noobs plus W archer. Like they are replacing in every round. So they will come to the right of A, and there will be at most one noobs plus W archer. So when we have cyclically gone to n-1 rounds, then all targets except A would have at most one noobs plus W archer. But since there are n such archers, because noobs plus W archers are n in numbers, so this means that the target A must have at least one noobs plus W, because it must have to be, because there are n targets and n such archers. And in n-1 rounds, I have proved that every target except A will have noobs plus W archer. So there must be an archer in A also. So this proves our above statement. So our assumption was wrong and the statement 1 above was true. Now that we know that within 2n rounds, we in every target, we have at least one noobs plus W archer from the start of the tournament. And since we know that once a target has noobs plus W archer, then their place will be fixed, because they can't win with the other one. So we can just say that once noobs plus W archer has occupied the seat in every target, then only the archer who belongs to the pro set will move, and they will cyclically go in n rounds, and after n rounds this arrangement will repeat itself. So after this arrangement takes place, only pros will rotate cylindrically for n rounds, and then this arrangement start to repeat itself. So therefore yes sir.
You have totally ran out of time, and now we were actually requested to stop this as soon as possible with the.
So just give me 2 minutes. I'll.
We don't have at least 2 minutes also to spare for you, because there are even more participants waiting for their chances.
So maybe because 2 minutes will help me, and I'll complete my
You
presentation.
ran out of time, and the highest thing that I can give you is 60 seconds.
Okay, so basically, yes, sir, I'm taking 60 minutes. And so basically, if I talk through this, so we can replace these R rounds with 2n and R modulus n, because 2n rounds, they will fix their position. And then in every n rounds, the arrangement will repeat itself. So basically, this was the simulation I did for the test case. It is of no use. And now coming to approach part. So I'm taking input, I'm taking the targets and rounds in n and R, and then I'll take an array of 2n where I will input the ranks in and positions. And now coming to the operation part, I run a loop for every target starting from 1 to n, and in every this for loop, I will fix the position of our concerned target, our concerned archer. We will fix his place, and then we will take a vector of set. And every set will contain 2 archers. Every set means one target, and we will contain 2 archers. So we will insert archers in that according, and in every iteration we change the position of H. We will change the position of H, and other archers will be inserted sequentially. So now we just have to iterate through the R dash rounds I calculated, and for every round we iterate over the whole array, take out and just we will compare the position of these. They will be sorted accordingly, and then we just have to cyclically move it for the R dash rounds. And while iterating, we keep track of the position of H and store the minimum target it can achieve. And if the minimum position of H is less than the previous iteration, so we update the initial position of H in our answer, and it will be fixed, and the minimum position I of the minimum initial position will be our answer, and we will print it. And coming to time complexity part, so it basically takes r dash rounds, and every round takes n into some constant time. So basically this is n square. It has become n square because r also depends upon n. So it basically becomes n square. And then coming to the, I have fixed every target.
Hello, Harshit. Hello, Harshit.
Yes, ma'am.
I'm really sorry to interrupt you, but we are done with your timing. And
Okay,
can we please have judges with their questions?
Yes, ma'am. Yes, ma'am. Yes, ma'am. It's okay. My solution is already complete. Okay, ma'am. So I have time complexity of
Judges, can we
1.
please have the Viva questions now?
So I'll start it off.
Yes, sir. Yes,
Good
sir.
solution,
Good evening, sir.
Harshit. I feel like I have not verified the mathematics, but I feel that this will yield an optimal solution. So
Yes.
congrats on that. So
Thank you, sir.
just a quick question on the first time complexity that you suggested, which was n square into r. Can you explain what algorithm you are planning to use there?
Yes, sir. So basically, at first, I said that it will be a trivial solution to just try out all initial positions. So in this time complexity, I will try out r rounds, and in every round, I will just iterate and compare the neighbor position of all the archers, and by comparing I will shift them accordingly. And this will basically, because we are doing it for n times and n times in an array, so we will take n square time complexity for that, and we must have to try it for r rounds to come to a conclusion and get our minimum initial position answer. So this is just a trivial solution that we have to try out all the initial positions, try out all possible initial positions, and just check the answer for all the positions. So that was the O(n) square, and I reduced it to O(n) cube.
So do you think like n cube, I mean, n to the power 3 is, you have reduced the complexity?
Yes, sir, because in the question it is given that, wait a second. In the question it is given that r can be 10 to the power 9, but n can only be 2 into 10 to the power 5. So it will definitely reduce our time complexity in worst case.
Okay.
Yes, sir. So maybe it can be done in less time complex.
Hello. So, judges, do you have any further questions related to Harshit's solution, or should we move on?
I did not have anything else.
Prashant sir.
Yeah, I don't have, but I just wanted to understand like how n cube, is saying like it has been optimized and n square is somewhere it was more.
Sure.
So I wanted to understand that.
Harshit, can you please
Probably I can explain that very quickly. So the brute force approach that he gave, that was n square into r. Now r is not in order of n. So what he did was he brought down this complexity from n square into r to n cube by giving his logic that the archers from rank n plus 1 to 2n will always occupy seats 2 to n and will stay there for 2 rounds after 2n rounds. So initially, let's say if n is 10 and r is 1000, then the initial complexity would have been around 100 into 1000. Then he optimized it to 1000, that is n cube. So that was his solution. I have not verified the mathematics, but the approach looks good to me.
Okay. Okay. Yeah, I think we can move on to the other one.
Thank you, sir, for your time. Thank you, sir.
Arshit is there. I think that he has joined again. So if judges have some more question, he is ready.
Judges, may you please let us know if you want to ask further to Harshit?
Yeah, I'll go with one more question then. Harshit, in your optimal solution,
Yes, sir.
what would your space complexity be? Like, would you require additional space to keep track of modifications?
Sir,
I am sorry, you're not audible.
Harshit, you are not audible.
I think there's a network issue on this side.
Sorry, sir. I guess he is having some network issues.
Yeah, we can move on to the next one.
Can I go to the next one, please?
Yes, please. Thanks.
Thank you, sir. Now I would like to call Ms. B. Kavya to present her. Ms. B. Kavya, are you present? Ms. B. Kavya? Next is Anustha Tamrakar. Next is Anustha Tamrakar. Are you present?
I think that there is some problem in the connectivity. You please call their name available from the participant in the Zoom. That would be more fine, and that will save our time also.
Can we please have Soumya Mishra finalist? Soumya Mishra, can you please join us with your audio and video on?
You are
You are not-
visible, but you are not clearly audible. You are not audible still. Can you please check it out fast? You are still not audible.
No, Soumya, you aren't audible.
Can you please unmute your mic?
I think that till the time she is trying to arrange, we can move to the next one.
Yes, sir, we are moving on to
You are
the next
requested to
finalist.
resolve the issue as soon as possible.
Soumya, you can try and resolve the issue as soon as possible. We will move to the next finalist, that is Rishabh Chauhan. Rishabh Chauhan, can we please have your audio and video on?
Yeah, good evening, everyone. I will share my screen.
Rishabh, you're requested to present whatever you have within 10 minutes and you won't be provided more than it. So make
Sure, sir.
do it as soon as possible.
Yeah. So, good evening, everyone. My name is Rishabh Chauhan. I'm from SRM University, Andhra Pradesh, currently in my first year. This is my presentation. This was the problem statement given to us in which we have to find the appropriate position or target on which our player can stand so as to end up at a number or target as low as possible. This was the code or the algorithm that I used. This is the whole program, working program. I have made certain sample test cases also for it. These were the sample test cases for the code. These are various sample test cases I thought from myself, and they were coming out to be perfect. And this was the problem solving approach I used. First, we are given that there are 2n archers with different ranks arranged randomly in pairs of 2. We are given our rank at the first index of the array, and there are R rounds. And at the first, when I saw the array, I thought that numbers are natural numbers and arranged randomly. So somewhere or the other, we'll have to sort them. So I used another array, stored all the elements of the first array into the second, and then I sorted it using the standard sort function. And then I took out the position of my player where I stand. That is the A0 position, first index position of the first array. And using that index, I also counted the player just below it, so as to get the position at the end. Before that, the index of my there were 2 conditions that I noticed, that if the index of my rank came out to be last, that is, I am the last person, I'm the worst player, then I'll simply return 2, as no matter how many rounds are there, if I started at 2, I'll end up at 2 even if I lose. And if the index was 1, or I was the best player, then I will return 1, as I will always be at the first position. Then for the other case, I stored R mod 2n. That would be helpful if there are continuous rounds and we are going on a loop, like we are going from second target, then certain rounds are complete and we return to again the second target. So that would be helpful in that. And then I initialize a target variable and searched for the rank just below mine. And as in the last round, my player can defeat one just below him. As my player can defeat just below him, so I'll return that and break the loop if found, or else I'll keep incrementing the target. Now, since R is greater than 2n, I knew that at least once my player will arrive at some target. Like I said, why I used R mod 2n. This is the use case of that. It will, you see, if the rounds are keep on going, so at a position, he'll again come at that position and maybe again. So after that, I use the remainder so that when he arrives at the target, I'll increment the target by remainder so that that particular position is found where he can stand and end up at the lowest possible target. And if the target by chance exceeds the range of numbers n, I used target mod n to keep the target in the range of the numbers. And this was the basic algorithm. Input the size and then sort, create another array, search for the first element, and second and storage index, make a variable below and just greater than my rank, and then store this in rem, then create target and initialize it to 1. Now search the below the just greater than my rank and keep on increasing the target variable. When below found, break the loop, and all these conditions for keeping the target in the range. And this is the time complexity. The best case would be omega n, or order of n, and the worst case would be order of n log n. The worst case came out since we use the sort algorithm of the standard library, as it has the worst time complexity of order of n log n. And the space complexity came out to be order of n plus k, where k is the auxiliary space, and n is due to I use another array to store the elements of the first array. Then algorithm analysis, as I created another array, so its size is 2n, and the range is 10 to the power 9. So the space constraint of my algorithm would be 1 GB around, approximately. And the worst time complexity is order of n log n. So the upper limit is of 2n is around 2n is 10 to the power 9, and around 10 to the power 8 operations take 1 second. So the worst time constraint would be 90 seconds, and the best would be 10 seconds. And I also found one limitation to my algorithm, as for the first rank, if I simply return 1, that would not satisfy this case, that return a number as large as possible. So I used this. This was the limitation in the algorithm, to return the remainder, so as my first rank can climb up so that the target is as high as possible, where my player starts and reach to the lowest position. And after resolving the limitation, this came out like 3. If my position is 1, so the output came out to be 3. Thank you, everyone. This was my presentation.
Thank you, Harshit, for the presentation and remaining within the time. I would now really request our judges to go through the question round. Please, judges.
Yeah. So Rishabh, I have a question for you.
Yes.
Let's say you are the best ranked player. Where would you start? Like, what would your answer be in that case? If you have 10 rounds and you have 20 players, what will your answer be?
And I'm the best player, sir. Yeah, so as I said, sir, I found this limitation. Then I'll take out the remainder from R mod 2n. The remainder which I'll get, like in this case, I like 4 and 10 are the rounds. My position is 1, so I calculated, and at the end, the remainder would be 3. So rather than giving out the target to be 1, I'll return it to be remainder plus 1. So as the target at which the player has to start can be maximized. And at the end, since I am the best player, I'll gradually climb up to the first place and remain at the first place.
So how many rounds were there in this input? 4 rounds, right?
No, 4 are the number of targets, and 10 is the number of rounds, and these are the players.
So you are saying you'll start at the 3rd target?
Yeah, I'll start at 3rd target. So as to
start at 4th target,
don't
you still end up at the first place in 10 rounds?
Yeah, 1, 2, 3. Yeah, then I also end up at the first.
Now, can you do a dry run and check? Like if you start at 4th position, 4th target, and you do it for 10 rounds, what will be the position?
The position would be first one. I'll end up at the first position at the end. So the position would be first.
So if you are the best player, doesn't matter where you start, you'll always end up at the
first. Yeah. But it depends on the number of rounds at the like how many rounds are there, because maybe we'll end up at like 2 players and 2 players 1 and
so I'll ask a different question in that case. Given the restrictions of the problems that you have, is it possible that the best player does not reach the first place? So I can tell
he'll reach.
Okay.
Now, one question I have read, you said like even if you are the best player and if you start at whatever position, you'll end up in the first target. That is what you're saying?
Yeah, if I'm the best player, yes.
So assuming if you have a rank 1 and if you start at target 4 and if you keep on doing it for 11 rounds, what would be the position? Would it be still target 1?
Yeah, it would be target 1, as I'll win at the target 1 and I'll remain at that position.
Okay, so once you reach target 1, you are not going to change the position because you will be the winner and you'll be staying there in the target 1 position.
Yeah.
Okay, and can you go back to your slide where you showed the time complexity?
Yeah. Yeah, this was.
Yeah, so when you say best case order of n, what is this best case? Can you give me a sample test case for this?
Sample test case would be like we are in all the for loops I've used, it is going to from 1 to either 0 to 2n or 0 to 2n minus 1 or 1 to 2n minus 1. So for those for loops, the order of the time complexity is order of n only. But the worst case is coming out due to the standard sort function that I've used, because it has the worst case to be order of n log n, and best case if it uses another algorithm and the array is sorted already, the best case would come out to be order of n.
Okay.
a follow up on that. So you are sorting, like your code does not know it. Your problem is taking a best case solution, like the input is a best case that you could get. Your problem does not know that, like your code does not know that. It will
Yeah.
still compute, right? So it will still perform the sort operation. Doesn't matter if your array is sorted. So do you think that in any case your O of n would ever be reached?
So if the standard sort uses it uses the best algorithm that it can use from the library, and if it uses if it uses erratic sort, and we know that for erratic sort it is order of n only, order of n into k. K is the number of unit I mean the places. So since it is 9, that would get cancelled out. The places are max to max, these are 9, and we left with order of n only at the end.
Okay. Okay. I had one more thing, like somewhere you mentioned the space complexity as well, which was n plus k, right?
N plus k, yes.
So what is k in terms of your inputs? Like in your input, you have n, you do not have k. So generally you give your answer in terms of the inputs that you have. Like input was number of players, which is n, and number of rounds, which was r. So can you give a space complexity in terms of that?
The k is the auxiliary space, obviously the code that the space that the code occupies, and the array, the second array that I used, that was of size 2n, that uses the extra space above the code, over the code, and so as to end up with a space complexity of order of n.
So you're saying this would still be O of n?
Yeah, because k is almost constant. The auxiliary space we generally we don't write while giving the space complexity, but I mentioned it so as to be very precise.
Okay.
I would like to ask the judges if they had further questions to Vishal.
Don't have any.
Do not have anything.
Okay. Thank you, everyone.
Yeah. Can all the participants switch on their camera? We'll have to take a good photo. Okay. Yeah, okay, so we are done with it. Soumya, is your mic working?
You're not clearly audible still now.
You can try switching off your video if that helps.
Soumya, you're still not audible.
Clearly audible still. Really sorry to interrupt you, Soumya. You are not at all audible.
Soumya, you are given one last
Okay,
chance.
by the time Soumya tries and resolves her issues, can we move to the next finalist? Can we please have Indu Verma? Indu Verma, can we have you presenting? Are you there?
Indu Verma, are you present?
Indu Verma, can we? Okay, I guess there is some problem with his presence. Can we have Arnav Goyal presenting? Arnav Goyal, can you please have you presenting? I guess there is some problem with his presence too. Soumyadeep Chandra, are you there presenting?
I think that Soumya Mishra is there. Please ask her to present.
Soumya Mishra, can we have you presenting with the proper mic setup? Soumya, there seems to be a voice lag yet again. Okay, can we call the next participant? It's Sudhanshu Yadav. Is he present here? Sudhanshu, can we have you presenting? Soumya? Soumya, can we have you presenting with a proper mic setup?
Hello, can you hear me now?
Yes, Soumya, we can hear you.
Okay, start presenting. Just give me 1 minute.
Please exit audio from one of your device. Please exit audio from one of your device.
Hello, is it okay now?
Yes. Yes.
Okay, just 1 minute. Let me share my screen.
Soumya, I would like to request and remind you too that the presentation should only last for 10 minutes and you have to end it up before it.
Yeah, sure. 1 minute. Let me just. Is my presentation visible?
Yeah, it's visible.
Okay, so good evening, sir. I'm Soumya Mishra from KET University, and I'll be explaining the algorithm I use for solving the problem statement given. So, sir, as we know that the main aim of the code to be written is to find out the rank of each archer, the arrangement of each archer on the line, and to finally output the target number on which I should stand to have a higher probability of winning the tournament. Now I'll give the complexity analysis of the algorithm. So first we'll optimize to the order of n cube. So the trivial solution is to try all possible starting positions and simulate the tournament for each round, giving complexity of order of n square r, which can then be reduced to order of n cube. Now we consider the archers numbered from n plus 2 to 2n, which is the final number of archers. So now we can call them the weak archers. So after we are done with n minus 1 rounds, the first archer will be on target 1 and will stay there until the end. From this point, if we consider the set of n archers consisting of archer number 1 plus the n minus 1 weak archers, which we will call the weak plus 1 set. And if we imagine the targets arranged in a circle, 1 to n, and then 1 to n, and then again 1, then we have two cases. First, when our archer from the weak plus 1 set competes with an archer outside of weak plus 1, then the weak plus 1 archer will stay on the target and the other archer will move. Now, when two archers belonging to the weak plus 1 set compete against each other, one of them will stay and the other will move to the target to his left, as given in the question. So after enough number of rounds, which is less than 2n according to the constraints, the weak archers will occupy the targets number 2 to n, where we will have one such archer on each target and who will stay there until the end of the tournament. Now, once a target is occupied by a weak plus 1 member, then it will always be occupied by at least one, because weak plus 1 members never move out of their target unless there is another weak plus 1 archer to replace them there. So that within n rounds after archer number 1 has arrived on target 1, every target will have at least one weak plus 1 member on it. Now we consider all archers that don't belong to weak plus 1. If we have weak plus 1 archer on every target, this means we also have one non-weak plus 1 archer on every target. So since under this scenario, the weak plus 1 archers always stay where they are, this means that the archers number 2 to n plus 1 will cyclically rotate around the n targets, periodically repeating their positions after every n rounds. So if we replace r by 2n plus r and magnitude of n, we would get an identical answer, because the outcome of tournament after r rounds would be identical to our outcome of 2n plus r mod n rounds. And it will always be greater than or equal to 2n, as said in the question. This concludes that we can easily improve our O n square r algorithm to O n cube algorithm. Now we will optimize to O n square. Now there are three types of archers. Ones that are better than us, which we can call the black archers. One that are worse than us, which I have considered as the white archer, and one that is us, which I have denoted by the gray archer. Now, if two archers of same color will be competing against each other, it does not matter which one retains, because when two archers of different colors compete against each other, the archer of darker color will win. Now, we will have three different cases here. First is when there are no black archers, which means that the best archer in this case, that we are the best archer in this case, and it is and that our target to start is on target n. The second case is when there is at least one black archer, but no more than n black archers, which means that our rank is between 2 and n plus 1, which means we are part of the group of archers that eventually ends up circling the targets periodically. In this case, we can note that we do not need to simulate the full tournament, but only what happens on target 1. If we know who competes on target 1 every round, then just observing when between rounds 2n and 3n, the gray archer, that is us, we get to compete against archer number 1, will tell us where the gray archer will finish the tournament. To find out about this, we can use an algorithm where we assign each archer a number p, which indicates the earliest possible round where the archer might compete on target number 1. So initially each archer's p number equals his original target number. Then we simulate each round of the tournament. For this, we determine who is competing on target 1. So the first archer there is the winner on target 1 from the previous round. His opponent can be determined by taking all archers with p number less than or equal to number of the current round. So the best archer among them will now be competing on target 1. We then compare these two archers and assign the loser a p value equal to the number of current round plus n. So this is the earliest round when we might see a archer back on target 1. Since we make no distinction between same colored archers, we can represent any set of archers by just 3 numbers, the number of white, gray, and black archers in that set, which allows us to execute every step of algorithm in constant time, because all we have to do is determine the color of best archer in set of candidates. So we only need to simulate up to round 3n. So, and the third case is when there are more than n black archers, which means our number is more than n plus 1. So we are one of the archers who end up standing on same target till infinity. So we only need to determine that what target that is. For this, the algorithm that I have used in my code is that since our number is greater than n plus 1, all white and gray archers belong to the weak set. Thus, we need to simulate how the white and gray archers push each other around. So we start at target 1 where we know no white or gray archer are pushed. We start at target 1 where we know no white or gray archer would be allowed to stay. So then we try to count how many white or gray archers end up getting pushed around the circle after every target. So initially the white or gray archers pushed from 1 to n would be those that were initially at target 1. Then we move to the target n and we add any white or gray archers that start there to the ones we transfer from target 1, and we can leave one of the combined sets there. So we keep on going around the circle from n to backwards, n minus 1, n minus 2. So on every target, we select any white or gray archers that and we leave one of those who we have picked either earlier or now. So eventually we get to target 1 like this. And if we have any white or gray archers pushed to target 1, we transfer them to target n and keep on going with same procedure in a cyclic manner. So when the second time we return to target 1, we will not have any more white or gray archers to push around, because in 2n rounds, every white or gray archer would have settled on a target. So this algorithm runs in linear time and space. So the optimization of this tournament from ON square to ON has improved our solution from ON cube to ON square. Now the last optimization required to bring the complexity of our algorithm down to order
Sonia,
yes.
You are requested to go a bit faster. You're running out of time.
Yes, I'm sorry. I'll just go faster. So I'll just explain this quickly. So if we if we let t denote the number of times the gray archer moves from target 1 to target n, and if x is the final position of gray archer, then we describe the outcome of simulation as being the number x minus n into t, where we can think of every transfer of gray archer, that is us, from one target to another target as decrementing outcome by 1. So we consider the algorithms I explained in the previous slides, and we can observe that if starting position is higher, then the final outcome can never be lower. Now that we have the relation between starting position and final outcome, we can find the optimal starting position as well. Now, since there are only n order of rounds being considered, the range to search is of order of n, so that O1 binary searches are required. So our complexity would be 1. So each binary search requires starting positions of order log n to be tested, which gives us time complexity of order n log n. Now the approach that I've used for writing the code is as shown on the slide, where I firstly wrote a simulation of tournament of order n, giving us starting position. Then I wrote a binary search segment to search for the best place to start among given range of positions, and finally check for wraps and return the desired target number. So I would finally want to conclude my presentation by listing a few points as to why I think my solution could have been better. Firstly, I think that the method of binary heaps could have been used to distinguish black or white archers, which seems more efficient, but I was unable to do that. And the linear time solution of this problem could have been generated, which I was also unable to do. And finally, I think that the solution of order n square log n could have been produced using binary search without optimization. So, sir, this is all. I can share my code if you want. So this is the code where I've already explained everything that I've done here. So I think I should not explain again since we are running short of time. So this is it. So here we are converting the RAM.
Have the question session.
Sorry.
Just Biddu sir and Prashant sir, can you please have the question?
I have a question. So Soumya, can you like I'm referring to the solution that you gave for n log n complexity. There, what were you doing with binary search? Can you explain that?
So with the binary search.
Yeah, I would say, can you explain your n log n solution once again? And then I had a specific question on the binary search part.
Okay, yes, sir. Just 1 minute. So, sir, in the n log n solution, what we were doing was, since our number was greater than n plus 1, so, like, oh, the binary solution. Yes, sir. So, as I said earlier, we let T denote the number of times the gray archer moves from target 1 to target n, and X denoted the final position of gray archer. So we described the outcome of simulation as number X minus n into T. So because we were thinking of every transfer of the gray archer from one target to another as decrementing the outcome by 1. So, sir, when we sir, then we found the relation between starting position and final outcome of the tournament, and after that we were first measuring the outcome of starting on target 1, then we were measuring it on target n. Then for each multiple of n in this range, we were using a binary search to find smallest possible ending position, which was greater than this multiple. Now, from the starting positions that we found, we were selecting the best one.
Okay, so my question here is the binary search part that you're explaining, that is not very clear to me. So can you explain to me, like when you're generally when we are doing binary search, we have a sorted list or a sorted array, and in that we are trying to look for a particular element, like the presence of a particular element. In this case, what is that sorted array of yours, and what are you looking for? Does that make sense?
Well, in this case, our array is the positions that we are looking at, because whereas finding the smallest possible positions in each case, and then we are searching in that list for the best possible outcome.
And your array will have set of values, right? Meaning 2 archers at one time for one target, right?
Yes, sir.
And then how do you do a search for that?
So here, Sir, in the optimization I was doing, sir, 1 minute, let me go to that part.
Because I do see like you are making a pair, right? So for each target, there will be a pair.
Yes. So here you can see I've compared these two. So 1 minute, let me look at my array. So first we are finding the target where we need to start. And then sir, from that we are getting a range of values from which we have to look.
So my question here is, how are you ensuring that after each search your list is in sorted order? Like the second element in the list, that has to be in sorted order for your binary search to work, right? And, I mean, only then can we use binary search. Otherwise it will not give you a log n complexity. It will go to ON if you are searching in an unsorted list. So where I am lost is, how have you sorted the list and then looked for values? Does that make sense?
Yes, I think this is where my code would be at fault. I don't think I've included this part.
Okay. Okay. Also, in your optimal solution, would you like, what is your optimal solution in this case? Time complexity?
So it was O1. So time complexity was N again.
Okay. And what was the space complexity?
It was 1, order 1.
So you don't need the initial list that you have.
So initial list of what?
So the initial list of ranks, initial array of ranks, you.
Yes, sir. I calculated that in the first part when I was optimizing to ON spell.
So will you not need to store those ranks for your ON login solution?
Yes, sir.
Then how is your space complexity a constant? Like, how is it ON in that case?
Sir, in that case, sir, I think I have stored it because that is how I wrote the code.
Yeah, so what will be your space complexity in that case?
Sir, in that case, my space complexity would be N.
Okay. And that is all I had.
Okay, sir, thank you.
Prashant, sir, can you please have any
Yeah, I don't have anything.
Okay, so finally moving towards the wrapping up of our event, I would like to present a vote of thanks to all of the chief guests, that is Biddu sir and Prashant sir, for spending their very precious time with us. The whole institute, the Emancipation Edutech Private Limited, is very grateful for that you guys have spared so much of your precious time to help us out with this event. Thank you to the organizers, that is Subir sir, Jayanti ma'am, etc. And thank you to my fellow anchors, Devashish and Animesh. We would like to wrap up this session now. Any word from Subir sir would be really kind as a wrap up.
I think that in place of my words, I think that the two judges, if they share the thought of the day, then it would be more fine, because I have already shared with them, And actually, I want to brief them all the purpose of the event. The purpose of the event was that the entire lot is moving towards Python and Java and advanced Java and React Native and so on, so on. But the mass that I have found has actually started neglecting DSA, data structure, algorithm, and the core and the basic part of the computer science. So the thought behind organizing this particular event was to put the students back to the track, that this is the track where they cannot deviate. So this is the main theme of the event. And I request both the judges to share few lines of their own thoughts related to this matter, so that this will help them out to concentrate more of their time in these core subjects. So I request first Mr. Prashant Jaiswal so to at least provide 2 lines, and then Biddu Singh.
Yeah,
Prashant, sir.
sure. Yeah, thank you, sir, for having me here on this hackathon. So yeah, I mean, I really like such kind of concepts, right? So where you ask all these students or anyone who is really interested in doing programming and all. So it provides a good platform, so where they can come up and showcase their ideas or the learnings that they have done all through this year. So as Subir sir mentioned, right? So DSA. So this is something like it's kind of a building block, right? So you can learn Java, you can learn C, C++, but those are all languages, right? So those are the languages which you just use to communicate to computer. But the whole thing that matters is how you build the blocks, and that is where the data structure and the algorithm comes in. So whenever you go for any of the product companies, right? So the main focus area would be like the data structure and the algorithm. So it may start with the smaller problems, right? So being array being the most primitive one and the most easiest one to learn, right? So you start learning arrays, then you move on to linked list, then you move on to tree. So these are some things like you should always keep focusing on, so that it can help you learn like what exactly you need to do when you are building a software and all. Because the basic thing would be when you build a software, you need to store the data. And how do you store the data? For that, you need to know the data structure and the basic details of it. So that will help you in actually identifying the things that are required. And similarly, right, for algorithm, when I say, so it's all about like how you solve a problem. So you come up with certain steps, you code it, and for that purpose you use a certain language, right? So be it C, C++ or Java. So the main focus area should be data structure and algorithm, rather than focusing on a particular programming language, because language keeps on coming and going, right? But the whole building block will stay, and that is going to help you all. So that would be my final words, to be focused on DSA.
Thank you so much, Prashant sir, for your for sharing your valuable knowledge of this topic. Can we please have Biddu sir sharing 2 lines on the same?
Sure. Thanks, Subir sir, for having me here. It was really a good experience interacting with students after such a long, not a very long time, but yeah, after 4 years, I think I'm interacting with students. So yeah, it was a good experience. In terms of my opinion of languages and data structures, I can probably say what I have done and what worked for me. So I picked one programming language and I stuck with it. I practiced everything on that programming language. That was Python. And I picked Python because it's very simple to code in Python, and you do not have to maintain some overheads like in if you're coding in C, C++ or Java. You'll have to always keep track of overflows. Like if you're using an int variable, you have to keep track of the value should not exceed the integer limit, or you'll have garbage there. So just to avoid these hassles, I prefer Python. And the basics in itself, as Prashant sir also mentioned, is data structures and algorithms. So practice a lot of data structures and algorithms, and I would suggest that if you're getting started, what worked for me is a site called interviewbit.com. It does have very good interface where you can write a code, and they have gamified the experience, so it keeps things interesting. That has worked for me, and in my experience, picking one language and sticking to it and writing all your data structures and algorithms code in that language will work wonders compared to switching languages midway. So yeah, that is my 2 cents. Thanks.
Thank you so much, Biddu sir, for your valuable words. I guess we can now wrap up our event.
Yes, from my side and the entire team Emancipation, I would actually want to name the entire team. So the man actually behind of this total program was Mr. Ranjan Tiwari. So I want to thank from the entire team to him, and Mr. Suranjan, Mrs. Jayanti Kumari. These all are my core team members. I have a very, very good organizing committee, starting with Animes, Devasis, Radhasri, and Devyansi. So I want to thank all of them, because without them, it won't happen. Actually, organizing anything does not mean that a single man can do. It is an entire lot of work, and we are planning this, I think that 1.5 months ago, and the thing that we have reached today, we have a journey of around 2 months to reach this place. I want to thank Mr. Prashant Jaiswal, who is really we can say that a guide, a member of the team Emancipation, and whenever we need him, whenever we need actually is present, is always with us. The Biddu Singh, we have access to him in a very short span of time, and I thank from the entire team that giving a time nowadays in a corporate world, it's a very tough thing. So I thank them to devote the time and to actually listen all of the participant presentations properly and asking them questions and giving them solutions. So thanks for their presence. And so I actually want to conclude the entire hackathon for today. Thanks, and have a very good career ahead. Thanks. Thank you.
Thank you. Bye.
Okay, thank you, everyone.
Bye. Okay.